ArthurTBenjamin, The Magic of Math, Solving for X and Figuring Out Y. Welcome to the magical world of mathematics, where numbers hold delightful secrets and astounding patterns. In the book summary of The Magic of Math, Solving for X and Figuring Out Y by ArthurTBenjamin, you'll discover the enchanting properties of numerical patterns and the power of mental arithmetic. You'll learn how math can be both beautiful and highly practical in real-life situations. The book summary demonstrates a party trick based on algebra and unveils the wonders of Fibonacci numbers. Brace yourself for a journey that explores the mysterious numbers pi, I, and e, the peculiar aspects of infinity, and the sheer beauty of mathematical proofs.
The magic of numerical patterns. Mathematics is more than just tedious textbooks and laborious calculations. The author of this book discovered the beauty of numerical patterns since he was a child. These patterns, made of numbers, are not only magical but also useful in the real world of mental arithmetic. The author employs the example of pairs of numbers adding up to 20, such as 9 and 11 or 10 and 10, to explain how these numerical patterns work. By examining the product of these pairs, certain patterns emerge, which apply no matter what number the pairs add up to. The numbers follow the sequence of 1 superscript 2, 2 superscript 2, 3 superscript 2, and so on. Understanding these patterns can enhance our mental arithmetic and make our calculations easier, such as squaring numbers. Instead of calculating 13 by 13, we can perform the easier calculation 10 by 16, where both numbers add up to 26, just like 13 and 13. By following the pattern, we can add 3 superscript 2 to the result to get 13 superscript 2 sad face 10 by 16, plus 3 superscript 2 equals 160 plus 9 equals 169. In conclusion, numerical patterns are not only fascinating but can also serve as practical tools in the real world. Mathemagics, the power of algebra. Learn how to amaze your friends with a party trick that involves the power of algebra. By following 5 simple steps, you can instantly guess 2 numbers your friend is thinking of and leave them amazed. This party trick is not just about impressing friends, but it also demonstrates the wonder of algebra and mathematics. By breaking down the steps and using basic algebra, you can see how to arrive at the original numbers that your friend was thinking of. Demonstrating how letters in algebra are used in place of numbers, this trick is an excellent way to show how fun and useful math can be. By using algebra to explain the steps, it is easy to see how the sum of 2 numbers can lead to finding the original numbers being added. The magic of number 9. The number 9 holds 2 fascinating properties. First, the digits of multiples of 9 always add up to 9. Second, the product of an ABCDE number and 9 always equals 9. The number 9 has mystical properties that have intrigued the author since childhood. One unique feature of 9 is that the digits in multiples of 9 always add up to 9. Even 99, which seems like an exception, adds up to 9 when its digits are summed. Additionally, any number whose digits add up to a multiple of 9 is itself a multiple of 9. For instance, the total of the digits in 123,456,789 equals 45, which is a multiple of 9, and so 123,456,789 is also a multiple of 9. Another fascinating aspect of 9 is related to certain numbers written in ascending order, such as 1 2 3 4 5 or 1 3 5 7 8 9. When one of these ABCDE numbers is multiplied by 9 and summed, the result is always 9. These charming properties reveal the magic associated with the number 9. The fascinating world of Fibonacci numbers. In his book Liber Abaci, Fibonacci introduced a problem involving rabbits that led to the discovery of a sequence of numbers that has remarkable properties. Each number in the Fibonacci sequence is the sum of its 2 predecessors. Adding the squares of Fibonacci numbers leads to a new sequence, where every second number is left out. The sum of the squares of Fibonacci numbers is the product of two consecutive Fibonacci numbers. The discovery of the Fibonacci sequence has led to various applications in different fields, from nature to finance. The power of mathematical proofs. Mathematics is the only science where propositions can be proven to be absolutely true. This is possible through the use of mathematical proofs, series of equations that hold true under all circumstances. For example, the proof that if m and n are even numbers, then m plus n is an even number can be written as m equals 2k and n equals 2j, with k and j being integers. It follows that m plus n equals 2k plus 2j equals 2j plus k, which means that m plus n is a multiple of 2 and therefore even. The power of proofs lies in their ability to establish certainty without resorting to endless calculations. Another powerful method used in mathematics is induction, where the truth of a statement for a particular number is used to prove its truth for all subsequent numbers. Mathematicians find induction particularly elegant. Mathematical proofs are the foundation of mathematical truth, and their use enables mathematicians to establish irrefutable evidence of the correctness of their propositions. The fascinating world of pi. Pi, the ratio of a circle's circumference to its diameter, has intriguing uses in math and science beyond geometry. It's crucial in the formula for the bell curve and the sum of fractions, and is an irrational number with many curious features. Pi, the ratio of a circle's circumference to its diameter, may seem like just another monotonous number from high school math classes. However, beyond its association with circles, pi has fascinating and critical roles in math and science. The concept of radius, diameter, and circumference are the basic building blocks of pi. To calculate a circle's diameter, twice its radius is taken. The distance around the circle is its circumference. Thus, the ratio of a circle's circumference to its diameter is pi, roughly equal to 3.14, irrespective of the circle's size. Mathematicians have discovered pi in many surprising areas, including the formula for the bell curve, which is used in various domains, including experimental science and signal processing. Additionally, pi is the result of an infinite sum of fractions that has no apparent relation to a circle. Renowned mathematician Leonhard Euler showed that the value of this sum, which is 1 plus 1/22 plus 1/32 plus 1/42, is equal to pi superscript 2/6. This connection between pi and an infinite sum of fractions is unexpected and remarkable. Intriguingly, pi is an irrational number, which indicates that it can't be represented as a fraction of two integer numbers. Notable examples of other irrational numbers are square root of 2. This makes pi unique and has confounded mathematicians for centuries. In summary, pi goes beyond its initial association with geometry and circles. It has critical functions in diverse fields, and its fame results from its perplexing properties. The most beautiful equation in mathematics. Mathematicians have a favorite equation known as EI pi plus 1 is equal to 0, which is considered the most beautiful equation in mathematics as it encompasses the 5 key numbers of math. I, an imaginary number, is the square root of -1 and plays a crucial role in solving complex equations. The Euler number E, approximately 2.71828, is like pi and used in calculating compound interest and bell curves. Despite their counterintuitive nature, mathematicians have found uses for imaginary numbers, just like negative numbers have their use in the real world, such as displaying debt. Exploring the bizarre world of infinity. Infinity is a mind-boggling concept that can leave us feeling puzzled. For example, the number 0.99999 is almost equal to 1, but will it ever be equal? This paradox can be explained by multiplying the equation by 10, which equals 9.99999. Now subtract the first equation from the second, and you get 9w equals 9.00000, which means that w equals 1. Infinity also shows that there are as many even positive integers as there are positive integers. This is because every number from the set of positive integers can be paired up with exactly one even positive integer. Mathematicians refer to this as one-to-one correspondence, which means that both sets have the same, infinite, number of elements. Infinity is a strange and deep concept that can lead to mind-bending realizations.
As we conclude, it's evident that The Magic of Math by ArthurTBenjamin offers an eye-opening perspective on the joy and astonishing patterns hidden within mathematics. This journey through the book's summary has showcased how numerical patterns can be practical for everyday use, and how simple algebraic magic tricks can impress your friends. We delved into the fascinating properties of Fibonacci numbers, the use of pi in various fields, the roles of imaginary numbers I and the Euler number E, and the strange world of infinity. Mathematics is indeed a world of magical patterns, only waiting for our curiosity and understanding to reveal its wonders. May this book summary serve as an inspiration for further exploration into the beauty and utility of mathematics.